Good afternoon, and welcome to Codeware's What's New in Inspect 2017 webinar. Thank you for joining us. My name is Brian, and I am a sales engineer at Codeware and one of the organizers for today's webinar. Today, we'll be showing off some of the new features available in Inspect 2017 Build 7700. Please feel free to ask questions throughout the presentation by typing them into the webinar control panel. We will do our best to answer as many questions as possible during the Q&A segment, and we'll post answers to all of your questions within a few days after the webinar at www.codeware.com/webinars. Now, I'd like to introduce to you our engineering manager and today's presenter, Matt Hyland.
Good afternoon, everybody. Brian, thank you for that introduction. Welcome, everybody, to the What's New in Inspect 2017. We have got a very exciting build for you guys this year, so I'm going to get right into it. Now, for those of you that have attended my previous webinars, you know I like to have a presentation up, and I also like to switch between the software because I always like to show you guys how we use these new features. So let's get right into it. So what am I going to be going over today? Well, today's topics, I'm going to be touching on some of the GUI changes. GUI is a graphical user interface. We've added some panels into the program for you to help you organize your vessels, exchangers, your documents, things like that, and I'll go over that with you. We've also extended our B31.3 piping document. We've added additional components such as elbows, T's, crosses, reducers, items like that. We've also added in API 570 for the mechanical integrity. So we've not only extended the components, we've extended the standards that we can use with our piping document. We've also added additional documents. So we've also added in B31.4. Now this has to do with transport piping. And I'm going to get into the difference between B31.3 and B31.4 momentarily. We've also added API 653 storage tanks, as well as a process system. And this is kind of like a miniature plant layout for your mechanical integrity, so we can actually start hooking piping up to vessels and tanks and bringing all of your equipment together. I'm also going to look at importing different file types, particularly a PCF file import. As well, I'm going to go through the new API 579 edition. We've added in the Part 9 crack-like flaw analysis for you as well. So I'm going to run through some examples, show you how we access it, run the analysis, things like that. So for the first part, I'm going to touch on the GUI changes as well as the B31.3 process piping. So I'm going to switch over to Inspect right now. So this is Inspect 7700. So as you can see, this is a new piping document with some piping that I built out here. I'll get into this momentarily, but I want to touch on some of the user interface changes. So the panels that I was just talking about. Over here on the left, we have a specification sheet data. And what this allows us to do is to make global changes to our vessels, our piping, our tanks very, very quickly. So for example, if you're in a meeting and say you have to run a what-if scenario, hey, we have to increase the pressure by 50 psi, we can type it in here on the left or, adjust temperature, things like that. So this is going to be available for each of the fixed equipment that you may have. And we've also added in a component tree over here on the right. So for example, if you click on any of the components, they will highlight and they'll zoom in for you as well. So it's just an easier way to organize your equipment. Now, if you click along the top here, you can actually drag this wherever you want. You can put it along the top, you can put it on the bottom. I just prefer to have it on the right. And just a quick note, there's a little pin option right here. So if you unpin it, it's still there, but you can bring it out and then pin it to it if you'd like. So that's there for you as well. But let's talk about piping. So as you can see here, this is our new B31.3 piping document. So I've modeled various pipes, flanges, crosses, elbows, things like that. But if you look real closely, you've noticed I've added in my inspection points. So the CMLs are now able to be modeled on my pipe run. In addition to that, right down here, I've added a damage mechanism. So not only can I combine my mechanical integrity, I can also combine my fitness for service as well. And as always, we are a 3D graphical program, so we can show you right on the model where your governing point is and how many years of remaining life you may have as well. And this is very, very useful when we're modeling it, because we all know the importance of getting a proper model to do any of this work is critical. So at least we can verify that the inputs that we put in are correct. Now, how do we go about setting this up? So let's actually go through setting up a pipe run really quickly. So I'm going to come up here, and along the top here, you're also going to notice we have the new documents, and that's what I just talked about before. So as you guys are familiar, we have our Division 1 document, our Division 2. So if we need to model Division 1 or Division 2 vessel, we click on either one of these icons. Heat exchangers, our new process system. But this new P3 option right here, this is our B313 piping document. Or if you got to do transport piping or tanks, you can click on those. Now, the critical part here, I want to stress to everybody, is that this is all within one program. You guys do not need to install separate programs to do a tank calculation, a separate program to do vessels, sometimes two programs to do a vessel. It's all within one program, so it makes deploying this very easy for you. But let's click on our new ASME B313 document. And as always, this is going to be our modeling environment. So we set this up identical to how we model vessels. So there's really no new learning curve here. Now, what you can do with the piping components, you can come under the component menu and select the components you want to start with. So I'll start with a pipe. And then we just need to let inspect know which direction we want to start in. I'll go in the +Y direction and click OK. From here, we start modeling the piping components. Now, I'll leave everything as a default. This is very similar to modeling a cylinder for a vessel. So I'll just go through this quickly. I'll make this 60 inches long and click OK. So there's my first piece of pipe. Now I can go back to the component menu, or as always, I can come over here and model my different components. So I'll put in a T in this one. Now when we model the next component, Inspect's going to ask us, where do you want to put it? Do you want to put it on this end or the other end? So these red arrows indicate where it's going to automatically locate. I'm going to click on it. I can rotate it, but I'll just click OK. And we can start modeling our piping system. So from here, let me put a piece of pipe on the top, and I'll adjust this to 80 inches, like so, and I'll add an elbow right here. Now, one of the other things that we can do in the program is we can also copy and paste components. Now, this is key, especially when we start getting a lot of components. So if you click on the component you want to copy, hold down Control-C and then Control-V, and we've copied it. We just need to know where you want to paste it. So just click on the end of the T right here, and we'll paste that component. So again, Control-C, Control-V, I can paste it. I can then also just simply come back and add any other models that I may want to, like so, that way. Let's put another pipe there. Now, one of the other really cool things we can do with this is when you click on a component, if you hold Shift down, if you hold the Control button down, the Enter Pipe Length button will come up. Now, if you're using a mouse with a wheel on it, you can actually adjust the length by rolling it, like so. So if you're making fine adjustments to some of your pipe runs, you can do it this way as well. Or you can simply just type it in and click OK. All right, so there's our pipe run. Let's say this is the pipe run that we're looking at. I'll just add some more piping here. But what I'm trying to show you is how easy and fast we can set up a pipe run, and then we're going to set up our mechanical integrity, and then we're going to look at some fitness for service. So from here, let's start putting our inspection points on. So again, we're dealing with piping, so the API 570 applies to this. So up along the top here in their menu items, you're going to have the API 570. So we're going to set up a new API 570 maintenance inspection. I'm going to click on it. Now right now I'm going to use the defaults. I'll use the inspection date of today's date. Again, all of this information can be changed later. So we'll just click next. Then you just need to let Inspect know what design conditions you want to use, as well as what class of piping service this is. And I'll click OK. Now one handy feature that we've added is what we call the automatic CML population utility. I'm going to let Inspect do this, and what this will do is, based on some basic information, we will actually do an automatic population of inspection points for you. So if you want to put 4 points around every circumferential seam at the pipe ends, or at different segments or increments along the way, you can do that. So I'll click OK here, and then we've now just populated our pipe run. So what I'm going to do is I'm going to set all of the thicknesses to the parent nominal by going to the Edit menu and selecting Set CML Thickness to Parent Nominal. What we'll do is we'll pull this over for you, and then I'm going to click OK. And as you can see, my inspection points have now been set up. So if you need to come back in here, let's maybe set up a new inspection, simply click on the maintenance inspection button right here, and it opens up the dialog. And then we can start making new inspections, calculating remaining life, things like that. The nice thing about using this program is you can actually copy and paste information in from, say, spreadsheets or data sheets as well. So you don't have to manually type this in. You can actually copy and paste this information in. Now, some of the other things that we've added in for the mechanical integrity are a checklist. So under the API 570 menu right here, there's an option for an inspection checklist library. And we've added in some for the API 653 as well as 570. So if I click on this, we've actually gone ahead and filled out a default one for you. Now, this is completely customizable. You can change the headings, anything like that, and then you can load them in so that in your inspection report, you can have a checklist. So if an author or inspector's looking at it or you're being audited, you can say, yes, I've gone through and checked this. Now, in order to add that into the report, again, I'm going to click on my maintenance inspection button right here. What you'll do is click on the inspection details option right here, and on the far right, there's a tab that says checklist. What we can do is load this in. So you can actually add in multiple checklists if you like. Click add. We're going to put in our external visual inspection checklist. Select. Now it's been added. So when I click OK here, I can run the report, and that checklist will be inserted into my inspection report as well. Okay, so we've gone through the modeling. We've gone through setting up mechanical integrity. Let's put some damage mechanisms on this really quickly. So if I come up to my API 579 menu, I can say, let's say we've got some local metal loss in one of the pipes. So I'll select local metal loss, and we can go through our fitness for service. So the part 4 and part 5 share the same dialogue. If you've seen any of my previous webinars, I go into that. But essentially what we would do is you'd run everything through part 4. If it fails that, then you go to part 5. But we're just going to go straight to part 5, and we're going to locate it on the pipe. And I'll put it on pipe number 2 right here. We'll put the metal loss location on the outside. We'll do a critical thickness profile grid, and then I'll just default some values for the loss to date, the future corrosion allowance, as well as the machining allowance. And as always, I'm always a big fan of running a part 3 brittle fracture assessment regardless of the operating history. So I simply check the box and I'll run a part 3 brittle fracture assessment. Click next, and then here's my metal loss input. So I'll do a grid of a 10 by 10, and I'll put my relative distance, safe distance away from any structural discontinuity. This is an example. And then I can start either filling in the metal loss like so, or what I can do again is copy and paste this in from a spreadsheet. Maybe you've logged it in an Excel spreadsheet or some kind of data logger. You can pull that information in. Click OK. And there's my metal loss. So as you can see, within a matter of minutes, I've modeled my pipe run, I've added API 570 inspection points, and I've added my damage mechanism so I can do fitness for service. The nice thing about this is, again, this tool can be used in different departments, things like that. So to run the calculations, as always, just go to the action menu and select Perform Code Calculations. Again, we'll run the flaw that I just modeled, click OK. And if you're familiar with Inspect or Compress products, you'll get an HTML report. We can also give you a PDF report as well, and we detail out all the calculations that we've done. So for the pipe, here's all the basic information, and then you're going to start seeing B31.3 references throughout the report as well. And then your metal loss will be located right there, and you can start going through your fitness for service assessment. You know, did it pass? Did it fail? If it failed, what do we need to do? Things like that. And again, everything is detailed out for you to make those decisions. Now, if I need to switch back to my pipe run, all I'm going to do is simply click on my report icon, and I come back to my pipe run. And at this point, either I can make changes to it, I can add additional components, things like that. All right, so that's going to be the B31.3 process piping. So again, I've added in elbows, T's, crosses, reducers, and we've also added API 570. Next thing I want to talk about is the B31.4 transport piping. Now I'll open up my example right here. So everything that I just showed you with the B31.3 is identical for the B31.3 process piping. So modeling the piping systems, everything is identical. Where the differences come is in the material sets. When analyzing anything to B31.4, we use a different material set, and we also allow full user-defined materials to be specified for these materials. Now, the other thing you may notice is that only the API 570 menu is available. There's a reason for this. Mainly because if you're in DOT jurisdiction, they don't allow fitness or service to be done. So typically, if you get below a T-min, you have to replace the pipe. So that's where we set up for our mechanical integrity. Now, one thing that we can also do here under the maintenance inspection, and I'm going to come back into this, so this is an inspection that was already set up, we can actually put in flags for you. So under the options menu right here, if we select calculation options, there's now an option for alert and structural min thickness right here. Now what we do is we default to the API 574 table 6. So what this essentially says is for all the available pipe sizes from an 8 up to 80, we're going to say this is the minimum structural T-min that we're going to use. But we want to be alerted when it gets a little bit higher than that. And this could be a conservative value. So again, we can set this to the API 574 for you, or you can adjust these. Different companies have different policies, so this is able to be altered by your own company preferences as well. And then that way we'll flag it. If it does get below the min alert thickness, you can then go out to the field and investigate it. Perhaps there's some local metal loss, and we can perform some additional analysis on it. Okay, so that would be the B31.4. So again, really what it is, it's a different material set that's used for the B31.4 calculations. All right, so let's get into the PCF imports. And one thing that we've added in here is the ability to load in PCF files. So instead of recreating your entire plant, a lot of programs out there, I know, for example, AutoCAD Plant 3D has the ability to export a PCF file. PCF, it's a piping component file, piping component format, however you want to call it. We can actually load those directly into Inspect. So now, when you come into Inspect, and we come to the File menu and select Open, we can actually load in a PCF file. So I'll take this one right here. I'll click Open. Actually, click Open right here, and it's actually going to recreate the PCF or the pipe run for me within Inspect. And there we go. So again, if you've got existing plant layout programs, or you have any of these programs, check to see if you can do a PCF file export. Because what you can do is quickly export them, bring them into Inspect. You can start laying your API 570, maybe your API 579 damage mechanisms over on top of this, and start doing your assessments. So it makes the workflow a lot more efficient for you as well. And then that way you can ensure that you're getting the exact pipe run that the layout department laid out for you as well. All right, so let's get into the next document that we added. We added an API 653 storage tanks. We've been asked for this for quite a while. People have been asking, can you please get into tanks? It's something we really want to see you guys do. And we've done this for you. So I've got an example right here. This is my API 653 tank, like so. So let's just go ahead and build a new one. So again, we're going to click on the T, or if you don't want to do that, go to the File menu, select New, and select API 653 storage tank. And we've set up almost a little mini wizard to help you walk through curating your 653 storage tank. So I'm going to click OK to this. Now this is how we're going to go about modeling. So you would tell Inspect a number of shell courses. We're going to put 6 in. The design method, we have the 1 foot or the variable point method, and then the diameter. You can also specify the riveted joints or if the material is not known, but we do have the materials available for you right there. And then the liquid height. So let's at 20, and we'll assume it's 1. All right, so at this point, the other option we have on here is that we can create a new inspection. That's really the point of doing all this. We want to start tracking your historic data. So you can uncheck this just to model the tank, or check this, click OK, and then we'll actually go through the inspection dialog. And again, this is identical to the piping, so your API 570, and the API 510 menu available for vessels and heat exchangers. So again, there's no new learning curve here. All the equipment shares all the user interfaces. So I'll click Next, click OK to my inspection intervals, do my automatic CML population, and I'm going to click Populate. And I'll just set this to the parent nominal. And there you go. Once I click OK, there's my tank, and now I can start setting up my inspections for my cylinders as well. So again, along the top here, we've got multiple documents for it. We've got Division 1 vessels, Division 2, heat exchangers, process piping, transport piping, and tanks now available for you. All right, so moving right along, the API 579. The API actually released the 2016 version last July. It is now available in Inspect. So we've updated parts 3, 4, 5, and 6, and we've now added in part 9. Again, something people have asked for. We can now do the assessment for crack-like flaws as well. And I'm going to show you how we're going to do that. So switching back to Inspect. What I'm going to do is take my vessel example right here. You can see I've got my API 510 points, my damage mechanisms modeled as well. Now, a couple ways to access the crack-like flaws. So let's say, for example, we have a crack-like flaw in this nozzle right here, nozzle N1. We can come up to the API 579 menu and select Part 9 crack-like flaws, and we can select the component from this list. Now, the other way of going about doing this is if you right-click on the nozzle, this would edit the component. We can actually go through the individual nozzle dialog. So I'll just click Next here because this is the first screen is really just setting up the nozzle. But on the second screen, there is a button down at the bottom that says FEA Details. I'm going to click on this. So this brings up the FEA analysis. So if you do want to run a finite element analysis for the nozzle, maybe you want to verify a nozzle design, you can set up in here. But there is an option within this dialog for Run Detailed FEA Analysis, and that's what we're going to click on. What this is going to do is launch the Nozzle Pro interface. As many of you know, we partner with Pollen Research Group for FEA nozzles. We've just extended that to include the fitness for service evaluation for you. Also included that is the saddle wizard as well. So if you have saddles that you want to look at, you can go ahead and look at that. So everything, all of the geometry, all the properties are brought over for you, so you don't need to set anything back up. But what we do need to do is define the flaw size or our crack. So what we're going to do is click on the API 579 Fitness for Service button right here, and we're going to fill out the flaw description. So it's a crack, and then the flaw location. Now we've got a bunch of different options for this. Now we can do anywhere in the nozzle, anywhere in the pad, or if you want to look at a cylinder or a pipe, we can do any or outside a pad, like so, and we'll do that. Next, we just drop down to the calculation controls. Now for the evaluation type, we have included some of the Part 5 local metal loss. So this is going to get into some of your level 3 assessment as well, and crack-like flaw or both. Now, why would I want to run both? Well, what we were finding is a lot of the cracks that were found in the field were also happening within local metal loss regions. So this is a way of combining it. But we're just going to stick to a crack-like flaw. And the proximity to the weld, it can be in the weld region or outside of the weld. Really, this is just to adjust for the weld joint efficiency. Now for the flaw information, now we can assume a flaw size. You can specify user-defined depth and length or maximum measured flaw depth and length. For this example, I'm just going to assume the default size and let it go. So the flaw has now been set up, so I can actually click OK. But since we're in here, I'll just go through the other tabs with you. There is the measurement grid, so again, if you want to run a Part 5 assessment, this is where we come to set it up. And there's also some optional information. For example, some of the advanced properties. If you happen to have any of the Sharpie impact test data, this is where we'd come to put it in. It is handy to have. It's not required, but it is an optional input. All right, so I'll click OK here, and let's run the analysis. So I'm going to click the Run FE button right here, and it's going to go through the analysis. So you'll see it right here in the center. It's going through its iterations, and you're going to start seeing the nozzle meshed as well. Once that's done, the results are going to be located within this window. So we get to keep everything within this window as well when you're looking at the flaw. So again, depending on the severity of it, it could take 10 seconds to a minute. It's now done. So I'll just click this away. What I'm going to do is expand this window for you. So this will be the results. So if you're familiar with this, on the right-hand side, we've got graphical results. On the left are the tabular results. Now I'm going to use a handy-dandy feature from Microsoft. I'm going to hold my finger down in Control and zoom in with my mouse. And what this will do is actually make the text a bit bigger. Okay, so you can see all of the results. You'll see the fitness or service results summary and then the calculations. So we're going to go to the results summary. Criteria has been satisfied. If you want to dive into it a little bit deeper, the calculations will all be listed below for you, so you can start going through and just verifying everything, or if you want to double check stuff, this is where you would come to do it, like so. And that's it. That's how we would actually go about setting up a crack for your Part 9 assessment. I'm going to exit out of this. I'm going to click OK here, click OK, and we're back in the model. So again, that's how we're going to go. Either you can come up here to the API 579 menu, select Part 9, or you can go through the individual nozzle dialog if you'd like as well. All right, then finally, let's touch on the process system file. Now this is something I find to be very, very useful, especially if you've got different departments and you've got inspectors, you've got analysts, things like that. So the process system is a file that organizes and ties everything together. So it does help with a little bit of the, I guess, plant layout, so to speak. But let's get into this. So I've actually got this example up. And this example is actually available in the 7700 build. So if you open up a new process system, we'll give you the option to open it. So if you want to play around with this, you can. But what are some of the things you notice? Well, we've got various types of compress files that were loaded in from our compress software. We've got piping that was brought in with PCF files, and it's all connected together. Now on the right-hand side here, we have the process system tree. Now this is really handy for a couple of reasons. One, it organizes everything for you, but what it does is it tells you what is the type of equipment am I looking at. So under here you've got plant vessel number 1. It'll actually highlight it for you, and then you've got piping circuits, things like that. It's actually along here on the tower. What this allows you to do is say, okay, I'm looking at a Division 1 vessel. Oh, I'm looking at piping, because you may have different people that look at different types of fixed equipment. So this enables you to tell what type of equipment you're looking at. What's really handy about this is that you can use it to train inspectors. So let's say we're sitting in our office, but you are not the individual going out to the field. You can actually talk with the inspector, let them know, hey, we need you to come up on this platform and have a look at this pipe right here, things like that. Now, what you can do from here is you can actually drill down into the individual files. So let's take this piping circuit that I've got highlighted. If I right-click on it, I can edit the file. And what this will do is actually open up the individual file within Inspect. So again, no need to go to separate programs, anything like that. So this is using our white background. You can change the background colors as well. But you can see here, this is the pipe run. So again, you can start putting in API 570. You can model API 579 damage mechanisms on this as well. You can save it. If you need to make changes to it, you can save it. And this will get updated in the process system file, like so. But how do we go about starting this? So let me just exit this. And we're going to start a brand new process system. So I'm going to go to the File menu, select New, and select Process System. So like all the other documents, it's going to come in with the same screen that we're used to with our modeling screen. And on the right here, what we're going to do is you can rename the process system. So if it's a plant location, a town it's in, it's up to you however you want to name it. What we're going to do is right-click on it, and we're going to select the option to add compress or inspect files. So again, if you're new to this, our inspect program shares the same .cw7 as our compress program. So if you have individuals or companies that you work with that use compress, you can actually have them send you their compress file, and you can load it directly into our inspect program. This ensures that you get the proper model. Again, critical for any type of mechanical integrity or fitness or service. and it also ensures that you got what was exactly built at the shop. So you know the nozzle locations are in the right place. So we'll click on this, and I'm going to bring in that inspect file that I showed you earlier. Click open, and we're going to bring it in. I'm going to right click again. I'm going to bring in that piping example that I showed you before. Click open. So you can see it's been added in here. Now we will put everything at the origin, but what we can do is we can actually move any of this equipment. So if I want to say, let's hook this flange up to this nozzle over here, what I'll do is just simply right click on the file that I want to move and select move equipment. And there's a couple of options for moving it. We can move it based on connection points. We can move it based on coordinates, by coordinates, to coordinates. We can rotate it, as well as we can choose a connection point from the list. And this is my preference. So what we can do is from piping example, we'll move it from flange number 2, and then we can select a nozzle from this list on the vessel. So I'll select nozzle 6A, click OK, and as you can see, it's been moved. And what's really handy, if you zoom in, you can rotate it, you can see those flanges have now been mated together. So you can start building out your plant this way as well, and start leveraging the power of having a program like this so you can have cross-departmental communication. So if you got somebody that just deals only with vessels, this individual deals with piping, you guys can start working together. Multiple people can be in this at once, so you can make changes, things like that. So that's how we would go about doing it. So again, just to recap, when you open a new process system, just right-click on it, select the add to files you want to add in, and then if you right-click on the individual ones, you can move them. And again, they will highlight so you know which one you're looking at, and it'll indicate if it's a Division 1 vessel or if it's a piping run. All right, so let's summarize everything I talked about today. So we've extended the component list for our B31.3 process piping document to include elbows, T's, crosses, common components like that. We've added in the B31.4 transport piping calculations for you. We've also added in API 653. We now allow you to do a PCF file import, very key if you want to save time bringing your pipe runs. We've got the updated API 570 edition, and we've also included Part 9 crack-like flaws for you as well. And we've included the process system document that I just showed you. So essentially, if you want to start hooking your different fixed equipment up, we can do that now. So at this point, we're going to open up for a Q&A session. So Brian, I'm going to turn it back over to you and see if any questions came in during the webinar.
All right, yeah, we did get a few questions. One of them is it possible to create a drawing from a piping run modeled in Inspect?
Very good question. Some of you may be familiar with our Codeware interface product, which is actually an add-in to SolidWorks and Inventor. We've automated some of the drawings now for our heat exchangers and vessels. Currently, we don't have an option to do that with the piping, but what you can do, and what I was finding, is that within those programs, if you can load in a PCF file, those programs are really good about taking that file and automatically generating a piping drawing for you as well. So I'd actively encourage you to explore down that avenue if you do need a pipe drawing.
All right, another question we got, when will Inspect include the latest API 579 rules?
Again, good question. We have actually already updated those, so they are available in build 7700 for you today. So when you update from 7600 to 7700, you're getting the latest API 579 rules.
If I make a pipe run in Inspect, can I send it to a colleague who only has Compress?
That is a very good question. Right now what we can do is if in Inspect you have a vessel or a heat exchanger, you can certainly send those to somebody using Compress and they can open it. So there is that, that cross-platform integration that way. With the pipe runs right now in the tanks, they can only be opened in Inspect. So if you are wanting to send it to somebody, they would need to have Inspect in order to open up the pipe run.
Okay, does Inspect include older API versions or only the latest?
Again, another really good question. What we do is with all the versions, when there's a new version of the API 579, We just released that, and the reason for that is that it's a recommended good practice to use the latest rules, because sometimes the older rules have been rewritten for a reason or altered because they may have found issues with them along the way. So we always encourage you to use them anyway. So with 7700, you're getting the 2016 version of the API 579.
And along the same lines as the previous question, does inspect include older piping codes?
Good question. What we did, so with the piping, I'll come back to my piping example. Just like with our vessels, we do include older ones. So if you right-click down in the bottom right-hand corner, right now we have the 2012 and the 2014 edition of the B31.3 for you. So what you would do is just right-click and select one of those two editions. And as the editions come out in years, we'll just continue to add them on here. So you will eventually have a library of those older codes as well.
Okay, looks like we have time for one more question. Is it possible to model elbows at a 45-degree angle?
Oh yes, good question. I'm sorry I forgot to show you guys this earlier. Yes, we can actually model 45-degree elbows. So everything here is 90. So let's model one right now. So let's take our example right here. So if I go and model an elbow, or if I right-click and edit one, what you can do right here, so when you edit the elbow, go to the second screen, and there's actually a few options available for you. We can actually do the standard 90 degree, we can do short radius 90 degree, we can do the 45 degree like you see here, but we can also do reducing and increasing elbows as well. So those all those options are available for you. So just select it from the list, click OK, and as you can see, there's a 45-degree elbow. All right. Well, I'd like to thank everybody for attending this webinar. This webinar is being recorded as well, so if any of you would like to view it later, or if you didn't get a chance to view it, we'll be posting it up online as well. And I hope if there's any questions that I missed, I will be going through them and answering them and then posting online. But I'd like to thank everybody for attending this webinar. I hope you found it very informative. Again, I've got one coming up next week as well. I encourage everybody to watch. Brian, I will hand it back to you.
Thanks, Matt. We will be posting answers to all of your questions online at www.codeware.com/webinars within the next few days. And if you have any further questions or would like to speak with one of our sales representatives, please email sales@codeware.com or give us a call at 941-927-2670. We'll see you next time.